Okay, so we're going to talk about how to solve any kind of proportion. Now, the method I'm about to show you works on any proportion, even if it only has one variable in it. If x shows up inside of it multiple times, no matter how many unknown positions, so let's say you have 4 positions, if no matter how many of those are unknown, you can use the cross product property to at least set up an equation to help you solve. So this is the method you'll use for solving any proportions. It's not necessarily the fastest one to always be used, but it's one that always works. And so remember, I want you to learn the steps of how to do it because you're going to need it when proportions get harder. So now let's see. Let's just take a generic algebraic proportion. Let's say we have a over b equals c over d. So those would actually be numbers in your problem, or at least 3 of them will be numbers usually, or something. So let's see. A over b equals c over d. Here's what we're saying. We're essentially saying the cross product property tells us that if you have a over b equals c over d, it tells you this will always be true. A times d will always equal b times c. Always. Now that can be written a different way. That can be written as d times a equals c times b. Or it can be completely flipped if you want. So b times c equals a times d, or c times b equals d times a. So now that sounded kind of lame. I was just naming a bunch of letters in different order. I'm aware of that. I just want you to realize the order you do it in doesn't matter. And I'll actually show you. I'll prove it to those of you who want to know how do you know you can do that. We'll talk about why in a minute. But first I'm just going to give you an example to help remind you of how to show you when it works, to show you that it works. So let's see, I'm going to make a proportion. A proportion is essentially 2 fractions that equal each other. Sometimes those fractions will be thought of as ratios, but they can always be written as fractions. So here's what we're going to do. We're going to make up a proportion. I'm going to make up one that has no missing values. So 2 over 7 equals, let's say, 6 over 21. Now, you know this is true because 2 over 7 is a simplified version of 6 over 21. If you take 6 over 21 and divide top and bottom by 3, 6 divided by 3 is 2, 21 divided by 3 is 7. You know that you could simplify this to 2 over 7, which means they're equivalent fractions. And if they're equivalent fractions, the word equivalent means equal to. So we know this is true. But now let's test it. Let's see if it's telling the truth. So here's what we're going to do. We're going to use the cross product property like we talked about. We're going to, over here, it was a times d. So that's essentially saying take the a and multiply it. So let's see. A times d gives us the left side. Now the right side was b times c. That was for the first option. The order doesn't matter though. You could have done d times a and then c times b, or done the other way around altogether. Do the b times c first. So here's what you do. We're going to multiply the same thing diagonally. So we're going to say, okay, I just out of habit go in this direction, but it doesn't matter. So we're going to say 7 times 6. All right, 7 times 6, thank you for that. Now, you then are going to go in the other direction. So let's see. 2 times 21, okay, that's 2 times 21. Now in this example, once again, we have no missing values, but I'm going to show you that it works because it's always true. So let's see, we're going to solve this equation. On the left side, we have 7 times 6. Well, let's see. 6 times 6 is 36. We add another 6 to that. So 7 times 6 is 42. 2 times 21. 2 times 20 is 40. 2 times 1 is 2. 40 and 2 give you 42. So you have 42 equals 42. And you ask yourself, is that a true statement? This is kind of like checking your answer almost. 42 does equal 42. That is a true statement. And so now this works no matter what order you multiply it in. Even if you did 21 times 2 over here, and then 6 times 7 over here. That would still give you 42 equals 42. No matter what order you do it in, it's always true. So remember this, all proportions can be solved using the cross product property. Now, I'll take a quick moment to prove to you why it's true, because some people don't understand, well, how do you know? How do you know you can do that? So let's see, if we had a over b equals c over d, we're going to use what we know about equations. That tells us the number 1 rule is you can do whatever you want to an equation as long as you do it to both sides. So what we're going to do is we're going to multiply both sides by something. We're going to multiply both sides by BD. So if we multiply both sides by BD, so times BD, times BD, now it's time to just figure out what does that equal. And you know when you multiply by a number and it doesn't have a denominator, we're going to give it a denominator. We'll make its denominator 1. So that's BD over 1, that's BD over 1. All right, so that's so great. So now we just have to multiply over here, and see what we get. So on the left side, we're going to multiply numerator by numerator, denominator by denominator. So let's see, BD times A really just equals ABD, okay? So we say them in ABC order and we have a bunch of letters, okay? So let's see, ABD. Now on the bottom we have 1 times B. Well, anything times 1 is itself, so that means 1 times B is just going to give us B. So we have ABD over B. Now it sounds like a bunch of letters, but I'll make a point in a second who cancels out. So now on the right side, let's do numerator times numerator. So that's going to give us BCD. Once again, I like to put them in ABC order, it is proper. And on the bottom we have D times 1, which is just D. Okay, so now let's see, you have ABD over B equals BCD over D. Bunch of letters, sounds kind of silly, but here's the real kicker though. If you'll notice, you have a divided by B. Remember, fraction bars mean divided. We have divided by B, but inside of here we also have a times by B. Down here we have divided by D, and up here we have a times by D. So here's what happens. Those cancel out. That B and that B cancels out. This D and this D cancels out because that says times D in there. That says divided by D down there. And because you have nothing but multiplying and dividing, you can just pull it out just like that. They cancel. So on the left side you're left with AD, and on the right side you're left with BC. Well, take a look. That's what we originally said. AD equals BC. So that's a way to prove it. And you can always prove it with numbers, but I was just using letters, using the properties we know about how to multiply fractions, how to cancel things out when you have multiplying and dividing of the same number, they cancel. So, and this helps you derive the cross product property. Now, you don't necessarily need to know this. This was just something if you want to be able to prove it, be able to understand the why. Perhaps you'll remember something you saw in here to help you. But that's the idea behind that, is I wanted you to know, where did it come from? We didn't just make it up. We actually found it by just saying, what do we know about equations? And that number one rule was, you can do whatever you want as long as you do it to both sides. And in this example, what we did to both sides was multiply by BD. All right, so now let's see. Why do we want to know how to solve proportions? This video is mostly going to focus on how to solve proportions, but one of the hardest things that people are going to have to realize is they have to realize, once you know how to solve a proportion, because after you get a bit of practice, you're going to realize, oh, that's easy, I can do that. And it will be true. You'll get good at solving proportions, and you'll be able to solve any proportion if you're given the proportion. The real test comes from when you have situations when you need to write a proportion to model a situation. So let's see, we'll at least do a few examples in this video of how to solve proportions. So let's see, if we have a proportion, now I'm going to make this one up, so it may have a decimal answer, may have an ugly answer, but so be it. But just know that we're going to go ahead and make it a problem that we're going to have to use a cross product property. So let's see, I'll make this first one kind of easy. So example 1, let's see, we'll make it 2 over 3 equals 16 over x. So now, if you think you know the answer to this, go ahead and pause the video for a moment and see if you know what this is going to equal. All right, so now, some of you may remember a way you learned in 6th grade how to kind of mentally solve some proportions when they're pretty like this. Pretty meaning we can ask ourselves, 2 times what gives us 16? You would say times 8. So 3 times 8 will give us x. That is true. But just know, don't get in the trap of always doing it mentally. I want to make sure you can prove it using the cross product property. Okay, so let's see. We're going to go ahead and we're going to multiply this direction. We're going to, that way diagonally. Cross means diagonally, product meaning multiply. So let's see. That gives us 3 times 16. Okay, and so now we're going to multiply in the other direction. It says 2 times x, so that says 2 times x. All right, so let's see. So the left side, 3 times 16, let's see. 3 times 10 is 30. 3 times 6 is 18. 30 plus 18 is 48. So that's 48 equals, now 2 times x, that one's a real head scratcher. It's literally as simple as shove them together. So it's just 2x. 2 times x is just 2x. Now let's see. You now have an equation. Look at this equation. It's a one-step equation. Use what you know about how to solve one-step equations. We know how to get rid of all coefficients by dividing. So you solve this by dividing both sides by 2. So those cancel, and you're left with x equals, let's see, 48 divided by 2, let's cut 48 in half. 40 cut in half is 20, 8 cut in half is 4, so half of 48, let's put those together, is 24. And that tells you x equals 24. And that's going to be the answer to your question. That's going to be the unknown value that was in this position. Now, we haven't talked about how to write proportions like this. We're assuming you're given the proportion and you need to solve it. So this is an example where we solved it. We found an unknown, I call them positions. We found an unknown position by using the cross product property. We multiplied this way diagonally, then we multiplied this way diagonally. Those two will always be equal to each other. Always, for all proportions. Okay, so now, let's try another example. Let's do one that maybe has some negatives in it. In this example, we're going to do, we'll say negative 5 over 8 equals, let's see, I'll say 20. So negative 5 over 8 equals, and in fact, we'll make that, we'll put 20 up here. So we'll make it a negative 20 over x. All right, so in this example, you still have one missing position. And whether you have one missing or you have an x over here as well, like let's say this was 8x and this was just x, no matter what, you're still going to use this property. So let's set it up. I actually kind of always do this as a reminder usually. We're going to multiply it that way, and then we're going to multiply this way. So let's multiply the red way first. So let's see, that gives us 8 times negative 20. All right, and now on the other side, we're going to have negative 5 times x. So on the left side, 8 times negative 20, so that's a positive times a negative. That's going to give us a negative. So that's negative. 8 times 2 is 16. The 0 comes along for fun, so that means it's 160. So negative 160. On the right side, negative 5 times x, we said just combine them just like that. So that's going to give us negative 5x. So negative 5x. So now we only have one step. We have a one-step equation. So we just have to get this negative 5 out of there to get x by itself so we can solve. Just like over here, you get rid of all coefficients by dividing. And in fact, you always divided this step. You always multiply diagonally, then you divide by whoever's next to x. That's what you always do. So we're going to divide both sides by what we're moving. And now, remember your equation skills. What you're moving is a negative 5. So that is what you're dividing by. You're dividing by negative 5. So now, these cancel. And now it's time just to see what that equals. So on the right side, the negative 5's cancel. We have just an x. Now on the left side, we have negative 160 divided by negative 5. A negative divided by negative. Okay, let's see. That's a positive. So we know we're going to have a positive answer. So ignore the negatives at this point. Now we just have 160 divided by 5. Okay, so when I think of anything divided by 5, I think of how many times does 10 go into it. So 160 divided by 10 would be 16. We know that 5 is half of 10, so that means anything 10 goes into, 5 goes into, but twice the amount. So if 10 goes into it 16 times, that means 5 is going to go into it 32 times. That's going to tell us x equals 32. So now, when you're working on this, I want you to say, okay, I've got x by itself, I now have a value. So that tells you know what x equals. X equals 32, which means that missing position over here, that's really a 32. So that tells you you've really got a 32 right here. And over here, you've really got a 24 right here. That's what value for x would make those proportions true. So that's using the cross product property. You remember, you can use this property for any proportion. All right, so now I want to try some examples where we maybe have a little bit more complicated example. So let's see. Let me pull up the bigger eraser so I can erase more at once. Because I'm going to leave the tips we already have. But we're going to do some different examples. Feel free to pause at any time so you can work out a problem before we solve it. That would be the smart thing to be doing, is to be kind of following along and trying these on your own. All right, so let's see. We'll do another example. This one's going to have more than just one unknown position. Okay. So in this proportion, I'm going to put 5 over 2x. Okay. So let's see, 5 over 2x, and we'll make that equal to, let's say 3x and on top we'll say 4. Okay, so now this one's going to have an ugly answer, but I want you to see that we're still going to do the same property. All right, so now, by ugly answer, I mean it's going to be one that does something kind of funny when we go to solve it, but I want you to know it still works. So we've got 5 over 2x equals 4 over 3x. We're still going to use the cross product property. So let's see, we're still going to do 2x times 4, so 2x times 4. We're going to set that equal to 5 times 3x. So equals 5 times 3x. Again, the order you write them in down here doesn't matter because 2 times 4 is the same thing as 4 times 2. They both equal 8. Well, in this case, 8x. So I already kind of jumped ahead on that one. But I just want to know the order you write them in does not matter. So that gives you 8x. Even if you have them flipped, that's okay. All right, so we have 8x equals 5 times 3x. Well, that's going to be 15x. So we have 8x equals 15x. So this is an equation we're asking ourselves, what value for x will make this true? And this one is almost kind of like a trick question in the sense of there is only one value of x that will make this true, and we're about to prove it. We learned when solving equations with variables on both sides, you always move your variables to one side. Well, let's see, one's over here, one's over here. We also learned we always like to move towards the bigger variable. In this case, it really doesn't make a difference, but we're going to do it anyways. So the smaller one's 8x, we're going to move that away. The opposite of positive 8x is negative 8x, thought of as minus 8x. So subtract 8x from both sides. So they cancel over here, but everything cancels over there. So now, because 8x minus 8x, that's everything minus everything that's over there, that gives you nothing, which is 0. So that side of the equation, everything canceled out. And if you have nothing over there, you can put a 0 there. Most definitely can put a 0 there. So now on the right side, 15x minus 8x, well, that's going to give you 7x. So we have 0 equals 7x. Now, we have a 0 over here. You can't do much with that, but we're going to go ahead and make a point anyways. You get rid of all coefficients by dividing by 7. So divide both sides by 7. Those cancel. And on the right side, you're left with x. And on the left side, 0 divided by 7, or 0 over 7, that's equals 0. So that tells you the only value for x that would make this equation true is 0. And that is correct. Look at the original equation we had. 8 times 0 gives us 0. 15 times 0 gives us 0. So that means we have 0 equals 0. So let's see, 0 equals 0. That is a true statement. So that tells us that 0 is the solution to our equation. And we can, and in this case, 0 would actually give you a 0 in the denominator, which you can't have. So I didn't mean to do that on purpose, but just know, for our purposes, let's just simply say x equals 0, but in actuality, you can't have 0 in the denominator since 2 times 0 is 0, 3 times 0 is 0. So ignore the fact that you're not allowed to have 0 in the denominator. We'll talk about that later, but just worry about the process that we did. The idea of cross-multiply and then solve for your unknown. So even if you have more than one unknown, you can still do it. And this is solving proportions using the cross product property. So remember, all proportions can be solved by multiplying diagonally both ways. Those two diagonal multiplications you do, they will always be equal to each other, always. So set them equal to each other and then solve for x. Our better examples were probably our first 2 examples. So now just remember, cross product property means you're going to solve for you're going to solve for whatever value you need that is unknown, even if it is the entire position or if it's just a piece inside of the position. So let's see, we'll do one more example just to make a point to make sure we're good. And I want you to also realize that when you're writing proportions, even though this video isn't going to talk about proportions, you technically can have your proportion upside down from everyone else's. And if so, that's fine. But just know you're still going to use the cross product property to solve it. No matter what you do, all proportions can be solved using the cross product property. So like I said, we'll do one more example. We have negative 2 over 7 equals, and we'll just say, we'll make this a positive, we'll make this a negative 3 down here, and this will be our blank. So now, this one's going to give us an ugly answer, but that's okay. So now we're going to use the cross product property. We're going to do 7 times x, which just gives us, so let's see, 7 times x, we know that'll give us 7x. Now on the other, let's do it in the other direction. So negative 2 times negative 3, so that's negative 2 times negative 3. Well, negative times a negative, that's a positive. 2 times 3, that's 6. So we have 7x equals 6. We're going to divide both sides by 7 to get rid of that coefficient. So those cancel. And we're left with x equals 6 over 7. 6 over 7 is a fraction. That's actually, because 6 divided by 7 is 6 over 7. So you could say your answer is 6 over 7, or you could find the decimal that 6 over 7 equals. So that was using another example of just solving any kind of proportion with a cross product property. We'll talk later about more in depth how to write your own proportions, but just know all proportions can be solved with the cross product property.